Hi everyone, welcome again to the Concept Academy. So today this is the first ever video on physics. So quickly we'll start with mechanics, and today we are going to learn distance, displacement, speed and velocity. It's the very basic of mechanics. And one thing is there, this chapter is aligned with IB MYP and Cambridge IGCSE physics. Okay, so without wasting any time, let's start. So we are going to study distance, displacement, speed, and velocity. But if we want to start with that, we need to know some very basic things. And what are that? Let's go see. Okay, so that is motion. So what is a motion? You need to understand what is the motion. Motion means any kind of activity we are doing which involves the change of place. That is called motion. Motion is a change in position of an object with time. Like suppose that it's Washington DC, and here it's New York City. Morning 8 o'clock, someone was there at Washington DC, and let's say evening 8 o'clock, that guy is at New York City. So that means, according to the time, the place has changed. At morning, that guy was at DC, and at evening 8 o'clock, that guy is in New York City, NYC. So that means the object is changing the position with time. So that is called motion. That means this guy has done motion, this object has done motion. Now we'll start with the 2D motion. So 2D motion means when object moves in a plane with movement in both x and y direction. So we will understand this when we will go and learn the graphs, different kind of graphs in this chapter. For now, we need to understand that motion is a change in position of an object with time. So let's go further and let's see what's the next topic. So now we are going to cover distance. Now if you are moving somewhere, you are changing your place. Suppose that your place is A in the morning and B at the evening. So that means you have changed your place. Use any object is there, and any object is there sometime before that object was at point A, and after some time that object is at point B. So now definitely this object has done a motion, right? So now when any object is doing a motion, so how much total length that object is covering, and the total path length covered by an object, that is called the distance. The same example I will give which I have given previously. One object was at Washington DC in the morning, and in the evening it is at New York City. Morning 8 o'clock, that object was at New York City, and evening 8 o'clock that object is at New York City. So that means motion happened there, motion has done there. Now, what is the distance? Then how much motion done, how much motion has done there? Like, what is the distance that object is covered? What is the distance between Washington DC to New York? The total length of the path from Washington DC to New York in this perspective, that will be called the distance. That means the total path length covered by an object. Suppose that a simple example, it's your school, this star is your school, and this circle is your house. So you're going from your school to your house, and you're doing motion. Like at 4:30 p.m. you are at your school, but after 1 hour or half an hour, let's say at 5 o'clock in the evening, you're at your home. So that means you have done a motion, and definitely there will be a distance, there will be a length between your school and your house. So that, let's say, that is 5 kilometer. So if you have done the motion of 5 kilometers, so 5 kilometer will be the distance. So it's a scalar quantity. Scalar quantity means the quantities which has only magnitude. It's very easy, scalar and vector, to understand. If you are expressing something only in magnitude, like when I'm asking to you that what is the distance between your house to your school, and you are saying, sir, it's 5 kilometer, or sir, it's 10 kilometer, or sir, it's 200 meters. So at that time, you are not telling the direction. You just said 200 meters. You said 5 kilometers. You said 10 kilometers. So in this case, are we mentioning the direction, that this direction? No, we're not mentioning. So that means when we are mentioning only the magnitude, the value, what is the distance, what is the height, whatever it could be. So that is the scalar quantity. Apart from these topics, if I will tell you to go to the market and buy one packet of Lay's, the chips, if I will tell to you, so you will go and you will buy a certain amount like 50 gram, 100 gram, but you will not say that 50 gram north direction and 75 gram south direction. So at that time, when you are buying the Lay's, you are checking the quantity that it's 75 gram or 100 gram or 50 gram, but you are not checking the direction. So that means that weight is a scalar quantity. We don't need to mention the direction. Meanwhile, we will go and we will learn the opposite of it, which is called vector. Now, what is vector? Vector means the quantities which has direction also, and the displacement which we are going to learn after this. That's a prime example of vector, which I am going to explain to you there. So now, as we know, scalar quantity where we mention only the magnitude, only value. We don't bother with the direction. That is called scalar quantity. Now, a person walks 3 meter north and 4 meter east. So one guy is there. So 3 meter north, that guy is walking, and then 5 meter east, sorry, 4 meter east. So the total distance will be 3 plus 4, that is 7 meter. Okay, so that's about the distance. This is the distance. It's very easy topic or very easy thing to understand. Now we are going with the displacement. Okay, now what is the displacement? The displacement is the shortest straight line distance between initial and final point. So now let's say it's your house. The star is your home, and this triangle is your school. So I'm writing school here. Okay, so now you are going from your home to your school, and your school bus comes at morning 8 o'clock, let's say typically 7:55 sometime. So you are boarding the bus, and your bus is going through this way, then this way, here, then here, this way. And after crossing a lot of places, your bus directly reaches to school. Okay. Now, this distance can be different. Like this is one, this, let's say this is 100 meter, this is 5 kilometer, and it's 1 kilometer. So some way, this will be also something, let's say 1 kilometer, this also, and this is also 1 kilometer. This we will say 4 kilometers, and this will be 8 kilometers something, and at the end 2 kilometer. So these distance are not measured. I'm just guessing. I'm just giving you just an overview that this is the distance. So when you will count all of these, when you will sum up all of these, this 100, then 5 kilometer, 1 kilometer, this, let's say 4 kilometer, and 1 kilometer, this way, when everything you will sum up, you will find out the total distance from your home to your school, because that's the way the path is designed. Okay, maybe there could be some houses, something else in the middle of the path, so your bus has to turn from this side and this again this side. So when you will measure this all, there will be the total distance, and let's say that it's 5 kilometers, not 5 kilometers, let's say it's 20 kilometer or 25 kilometers. But from your home to your school, there will exist, there will be, if you will see, and suppose that you have a drone, so you will see that there will be straight line, straight direction. This also can be possible. Like your bus is going like this way, going like this way, but a straight path, the straight distance is also there. So this will call the displacement, the shortest straight line distance between initial and final point. Your initial point is at home, and your final point is at school. So the shortest distance is the straight line distance. So this is called displacement. This is called displacement. Now, it's not possible that you every time you will go with the same path, straight line path, because as you see in the road, there are a lot of turns there. But it's also possible, it maybe it's not there, maybe the road is straight. So if the road is straight, you are going in only one direction from your beginning point, from your home to your school, only in one direction if you are traveling. So that means you are covering the displacement. This is the displacement. But If there are some objects in the path and your bus has to take some turns, so that means it's you are covering the distance. Now, the major part of it, the vector is, sorry, displacement is a vector quantity. It's a vector quantity. Vector means where we have to mention the value, that how much distance is there. Meanwhile, whatever you will say, displacement is a kind of distance. Let's say it's 5 kilometer. So it's the total length of the path which object is covering. But it's the shortest path and it's in straight line. That is the only difference. Displacement is distance only. Distance, what is distance? the the total path, the total length of the path from the beginning point to the ending point, right? But in displacement, two things are added. Displacement is the shortest distance possible, and it has it is straight line and it is a vector quantity. Hence we go in a straight line when we cover the displacement, so it's a vector quantity. That's why the direction matters here. For a simple example, if I will give, so here in this straight line, you need to tell the direction. You can tell the direction, you can mention the direction. How you can mention the direction? You can say that if someone will ask, how much far is your school? So you will say that, let's say this is the east direction and this is the north direction. So you can say that 5 kilometer east from my house. And usually we symbolize like this way vector quantity. This is displacement. So we show this arrow to show that it's a vector quantity. So displacement is a vector quantity. So now here we need to mention that 5 kilometer east, the displacement like we need to cover, that is from home to school, that is 5 kilometer and east. So that's why it's a vector quantity. And what is a vector quantity? Vector quantity is a quantity which has magnitude. Magnitude is the value, that is 5 kilometer, and direction east. If you will recall the previous thing when I've explained about the distance, that time we were not bothering about the direction. But for sure, in displacement, we have to do this. Okay, and the unit is same as meters. The SI unit, the International System Unit, is meters. So that's it all about it. So meanwhile, displacement and the distance, they both are same, but distance is a scalar quantity in which we don't bother about the direction, but in displacement, it's a vector quantity where we have to mention the direction. If we will not mention the direction, so that means we are not representing it properly. Okay, and now I'm going to give you a one quick example. So we will able to understand what is the difference between distance and displacement and what are the similarities. So one object is there, that object starts it's the initial point, and from A that object is starting the movement and it goes through this whole way A to B. Then from B that object is taking a turn and it's reaching to C. So this is the final point. So C is the final point. So one object is starting from A, reaching at B, taking a turn and reaching at C. So now we need to find out the distance and displacement. So what is the distance? How much distance that object covered and how much displacement that object covered. So let's see. So first we are going to find out the distance. So distance means the total length of the path covered by the object. So the object started from A, covered 6 meter. That means 6 meters plus, and then it goes to this way plus 8 meters. So 6 meters plus 8 meters. Now this will be the distance. So 8 plus 6 will be 14. So total distance cover is 14 meter. Simple, easy peasy. No need to mention the direction. Just write the value and you are done with that. But now when we talk about displacement, let's write displacement. So what happens in displacement? Displacement is the shortest distance. So if you will observe properly, this path which is already designed A to B, then B to C, it's not the shortest distance between A to C, right? Between the initial point and the final point. So now we need to figure out what is the uh, shortest path, what is the shortest part between A and C, and that's always a straight line. So what I'm going to do, I'm going to match the points A and B by using a straight line. So this way, here I have done. Okay. Let me make this line a little bit proper, then we are good to go. Okay, so now I think it's better. Okay, so after this, now this total path, AC line, this will be the displacement, because what is displacement? The shortest distance between the initial point and the final point. The initial point is A and final point is C. And this thing is not the shortest distance, but this thing is, as you can see, or you can observe properly, that this line is the shortest distance between A and C. And now we need to find out the total length of A and C. So how we can find out? So if properly you will see, this angle is 90 degree. So if this angle is 90 degree, so this whole thing is making a right angle triangle. So this making a right angle triangle. So then we can apply the Pythagoras theorem here. So that means, so Pythagoras theorem states that this, I will say, this is the base, this is the perpendicular, and this is the hypotenuse. So Pythagoras theorem states that hypotenuse square is equal to base square plus perpendicular square. So in the place of hypotenuse, we don't have anything, so we will write h only, h square. Base square is 6, 6 square, plus perpendicular, in the place of perpendicular there is 8, this is 8 square. So h square is equal to 6. What is the square of 6? 6 6 are 36, and 8 square, 8 8 jar 64. So now we have h square is equal to 36 plus 64, and now we need to add this. So this 6 plus 4 will become 0, 10th 0, carry will be 1, and 6 plus 3 will become 9, 9 plus 1 is 10. So after adding this, I'm getting 100. So now I'm making a small line here to solve it further. So I'm right here. So h square is equal to 100 we have from this thing. So now this will be h is equal to under root 100 or square root 100, and we know that the value of square root 100 is 10. So the value of h is 10 meters. So that means the displacement is 10 meter. So the distance is 14 meter and the displacement is 10 meter. I hope this thing is clear for you. If not, so you can put doubt in the comment section, and I will make a dedicated video between distance and displacement. It may be, mostly it will be a short, and you can have the screenshot, you can see the steps properly, and then you will able to understand. Okay, so now we will move further. Uh, Next point is speed. So what is the speed? Now we have covered the distance and displacement. So now we are going to learn about speed and velocity. So what is speed? Speed is the distance traveled by an object in a unit time. Like now if you have if you did ride with motorbike and car or anything, so you may would have heard that the speed is 70, the speed is 80, the speed is 100. So what is that speed? It means when the someone is saying, especially in India or any country, like in India, they take kilometer per hour, this thing, but in Western countries, we take miles per hour. So if someone is saying that the speed is 100 kilometers per hour, so it means that 100 kilometer per hour, it means that in 1 hour, in one particular hour, the vehicle is covering 100 kilometer. If the same thing, if someone is saying the speed is 50 miles per hour, so that means in one particular hour, that vehicle is covering 50 miles. Okay, like let's say it's again, I'm going to take the example, it's the Paris, and here it is Berlin. So this is Paris and this is Burning and Berlin, and we will take a typical distance. Let's say it's 1,000 kilometers. Okay, it's 1,000 kilometers is the distance between Paris and Berlin, and we are going in a road trip. Now, we are covering, we are, our average speed, the speed of our vehicle is 100 km per hour. That means in 1 hour we will cover 100 km. So if in 1 hour we will cover 100 km, so in 2 hour we will cover 200. Same in 3 hour 300, then 400, then 500, then 600, 700. And when we will reach, when we will be covering 800 kilometers. At that means we have taken 8 hours for that, because we are covering 100 km in one particular hour. That is the speed. So here we will reach from Paris to Berlin in 10 hours, because we are covering 100 km in 1 hour. That's our speed. So speed is how much distance we are covering in a particular time. That is called speed. So the speed formula is distance upon time, and the SI unit is meter per second. You need to remember this. And speed is a scalar quantity. That means you don't need to bother about the direction, just you will have to write the value. After calculation, you will put the value. And how you will calculate, let's see. So the basic example of this question, basic example for speed is, if a car travels 100 meter in 20 seconds, so we need to find out the speed. So speed will be, formula is distance upon time. So the car travels 100 meter, which is the distance. So in the place of distance, we will write 100. And then it is taking 20 seconds. So 100 upon 20, this will be 100 upon 20. And 100 upon 20, we know that 25s are 100. So this will be 5, and the unit is meter per second. As you can see, the distance in meter and time in second. So this will be meter per second. So 5 meter per second is the speed. That's it. No mention of direction. Why? Because speed is a scalar quantity, and a scalar quantity, we don't need to mention the direction. We only mention the magnitude, which is the value, and the value here is 5 meter per second. So this is the quick idea about the speed. Let's go with the velocity. So what is the velocity? Actually, velocity is the same. In speed, what we do in speed, we see that how much distance it covered, how much distance has been covered in a particular amount of time. But here we will see that how much displacement we have done in a particular amount of time. That's the only difference between speed and velocity. So let's see what is velocity. Velocity is the rate of change of displacement of an object with respect to time. It tells us how fast and in which direction an object is moving. Yeah, one particular thing is here, that velocity is a vector quantity where we need to mention the direction. So now suppose that here is the point A and here is the point B. Okay. So I will try to make a straight line for sure. So this is the straight and the shortest path. And this is which I'm going to draw. Now this is one random path. Okay. Now, is this, you can see that it's a straight line. This A is the initial point and B is the final point, and you are going through that. So when you go in a particular direction, when you're not changing the direction, you're going in a straight line. So that time you are not covering the distance, you are covering the displacement, you are doing the displacement. Okay, that's not the distance, that is displacement when you are moving in a particular direction in a straight line. But the above one, which I am going to mark with the blue ink, this one, in this you are changing the direction. As you can see that you are not going in a particular direction every time. So this is the distance. This AB, this thing also distance, displacement is also distance, but it's displacement, we will call it displacement. um, Displacement is the shortest distance. It's also a distance, but it's shortest. This thing also distance, and this thing is a displacement, A to B. This red whole line is the displacement, and blue line is displacement. Okay, so now if you are going to see that how much time we are taking to cover this whole path, this blue path, so at that time you are measuring the speed. When when you are checking that how much time we are taking to cover this path, and how in particular time how much distance this blue thing we are covering, so that time you are calculating the speed. But when it comes in the case of displacement, when it comes the place of displacement in the straight line motion, at that time, if you are trying to figure out that how much time we are taking to cover this, or in particular amount of time how much distance, how much displacement we are doing, so that is velocity. and it is a vector quantity. That means you need to mention the direction. Obviously, now displacement is a vector quantity and only time is extra there. So velocity is, the formula of velocity is displacement upon time, and this SI unit is meter per second. So now let's say if this thing is let's say 5 kilometers and it's a straight line, and you are taking 1 hour to cover this. So now, hence you are going in a straight line, hence you are doing the displacement. So in this case, you will find out the velocity. So displacement is the straight line direction, that the shortest distance. So that is 5 kilometer, and you are taking 1 hour to cover this. So 1 hour will come down, time, displacement upon time. So this will be 5 kilometer per hour is your velocity. Now is this enough? No, it's not enough. It is a vector quantity. That means you need to mention the direction. So you can write towards B. Towards B. So this is the complete thing. So the velocity here, what is going on, that is 5 kilometer per hour, and towards which direction? B direction. Towards B it's going on. So we need to mention it. Okay, so this is a quick idea about velocity. Let's go to the next part. Let's see what is the next. So here are some quick question in 2D. So first is, what is the definition of distance? I'm not going to repeat it. You can do it by yourself. Is distance a scalar or vector quantity? You need to answer the question. Can distance ever be negative? Yeah, this is an interesting question. Distance can never be negative because like zero means you are not covering anything. You are in one place, you are in point A and you are here only and you are not going anywhere. So the total distance covered means zero. So now if you will go here this side, 5 kilometer this side. So this will be also 5 kilometer. If you will coming back side 5 kilometer only, this will. So wherever you will go, so we have to measure it and it cannot be negative. So distance cannot be negative. Can displacement be zero even if distance is not? Yeah, obviously the displacement can be zero. In which case, suppose that you started your journey from point A and you are going to point B. Then after returning, you are reached at point A only. So your initial point is A and final point is also A. And the displacement is the shortest distance between the initial point and the final point. So our initial point is also A and final point is also A. So what is the shortest distance between A to A? There is no distance because there's the same point. So in that case, the displacement will be zero. How is velocity different than speed? So you need to understand that velocity is the vector quantity and speed is the scalar quantity. And in speed, we see the distance, we see how much distance we are covering in a particular time. And in velocity, we see that how much displacement we are doing in a particular time. Velocity, a scalar or vector quantity? I think I have given the answer of this. So I think this is the all. This is enough for today, and this is all about the speed, velocity, and we along with that we checked the distance and displacement. When we will go through the questions, when we will go through the different examples, so these things will be more easier for you. So please, if you will like this topic, so please hit the subscribe button which there below, and the channel name is Concept Kedemy, and you can follow us on Instagram. And if you want to get the one-on-one classes from me, so you can give me a mail on info.conceptacademy@gmail.com, and I will respond as soon as possible. If you have any feedback, any questions, so you can put it on the comment section. As soon as I will try to reach to you. So thank you so much for having me. Have a nice day. Thank you so much.